I'm Jonathan Kolmer from the University of Duisburg-Essen, and I'm the project leader for ERICA, which stands for Experiments on Rebounding Impacts and Charging on Asteroids. So in ERICA, we want to simulate the surface of a rubble pile asteroid, and we want to simulate this as realistically as possible. And so we need an experiment that provides the gravity that's found on the asteroid. We need to provide the vacuum like on an asteroid, and we need to provide material that's similar to the material found on the surface of rubble pile asteroids. So rubble pile asteroids are not one monolithic rock, but they are composed of multiple smaller rocks and gravel and pebbles and dust on the surface. And these rubble pile asteroids, they are quite common. And so it's also the kind of asteroid that a lot of current space missions are being sent to, like the Hayabusa missions or the OSIRIS-REx mission. We are pursuing two goals. The first goal is to develop the technology to simulate the asteroid environment. And this is done by placing the experiment in the Raman Drop Tower, which provides excellent zero gravity. And then on top of the zero gravity, we have an accelerating stage that provides the asteroid level gravity. The other part is that we address a scientific question, and this concerns the size sorting of rocks found on asteroids. There is the idea that if you have an area where you initially have a lot of small rocks, and then another small rock impacts this area, it's more likely to stay there than if the small rock, for example, impacts an area with big rocks. And this is one thing we are going to test here. What we specifically do is that once we are in microgravity, or let's say in asteroid gravity, we take this asteroid surface and then impact a particle from the top, and then have a series of cameras that record how this bounces off the surface or if it creates a big splash, and then we can track all the particles that are ejected from the surface. So one application for the technical part of the experiment is that now that we have this high fidelity asteroid simulator, we can use that to test ideas for novel instruments to interact with asteroid surfaces. One such an idea is a digger that's in contrast to current technologies where you use drills or pistons. We would suggest we use small flexible probes to dig into the surface, because we think they provide a better way to interact with the surface without needing a lot of power. So right now we're using the drop tower in catapult mode, because that's providing a very long microgravity time. But we are also looking forward to using the new GTP Pro, which perfectly complements that long microgravity time with a high repetition rate, where we can then look exactly at the moment of impact.